Dear students, as I told you in the previous class, now we consider steady state in the Solow model with the technical progress. And we have expressed technical progress as labor augmenting. And introducing technical progress as labor augmenting is akin to population growth, is similar to population growth, as technical progress is introduced as labor augmenting technical progress. And in the previous sessions, we have explained economy in terms of quantities of labor per head, output per head, etc. K by L, Y by L, etc. Also, we have considered the effect of increase in labor equal to N. And now we analyze economy in terms of quantities per effective worker and allow for number of effective workers to increase. That is, we now consider capital per effective worker using the notation K tilde is equal to K by AL, capital per effective worker. And we call this K by A by L as capital technology ratio. We call this capital technology ratio. Capital technology ratio, you read it as tilde, K tilde. In the previous classes, K, Y, etc. Now K tilde and Y tilde, Y by AL, and the production function is Y tilde is equal to function of K tilde. That is, output per effective labor is a function of, output per effective labor is a function of capital per effective labor. Now, given this new notion about the production function, our analysis of the economy proceeds just as our analysis of the Solow model with the population growth. Now, the steady state now is written as delta K tilde is equal to S of K tilde minus N plus lambda plus G K tilde. That is, in addition to N plus N plus lambda, an additional factor G is also introduced. So, as before, change in capital stock. Now, this is capital technology ratio is equal to S of K tilde minus N plus lambda plus G into K tilde. Now, as K tilde is equal to K by A by L, now investment involves three things to keep K constant. One is lambda K tilde needed to replace depreciating capital, N K tilde needed to provide capital for new worker, and G K tilde needed to provide capital for new effective workers created by technical progress. So, the difference is, instead of Y by L and K by L, we have k by al and y by al, and this capital dilution now has three terms n, lambda and g, and the steady state is defined as the point where s of k tilde is equal to n plus lambda plus g tilde. Now graphically we can represent steady state like this, as in the previous graphs. As in the previous class. This is k tilde, y tilde, and now this is s of k tilde n plus g plus lambda into k tilde. This is f of k tilde, and this is k star tilde, and this is y star tilde. Now, if the economy begin with a capital technology ratio lower than k star tilde, it moves towards to this, and if it starts with a capital technology ratio above k star tilde, it again moves towards k star tilde. And equilibrium, steady state, is defined with the intersection between n plus g plus lambda k tilde and s of k tilde. Now, with the addition of technological progress, our model can explain sustained increase in standard of living over time. Sustained increase in standard of living over time. That is, technological progress lead to sustained growth in output per worker. Now, let us consider these things in the form of a table to explain how the various variables behave in steady state when technological progress is also introduced. Now, the first we consider variable, symbol, steady state growth rate. That is, the first variable is capital per effective worker. K tilde is equal to k by al, capital per effective worker. Steady state growth rate is 0. Capital per effective worker is constant in the steady state. Then output per effective worker, y tilde is equal to y by al. It is also not growing in the steady state. Now, output per worker is y by l is equal to y tilde into a, y by l into a. Y tilde is equal to y by al into a is equal to y by l. So, y tilde into a, y by l is in the steady state, it is growing at rate g. Output per worker is growing at the rate g, and total output that is y is equal to y tilde into al, that is y tilde, y by al into al is growing at a rate g plus n. So, as you can see here, capital per effective worker is not growing. It is constant. Output per effective worker is also not growing. But as the efficiency of the worker is growing at a rate G, output per worker is growing at Y tilde into A, that is equal to G. Output is growing at a rate G. Total output is growing at a rate G plus N. So in this model, according to Solow model, only technological progress can explain potentially rising living standards. The reason is, when technology is introduced in the steady state, we have output per head or per capita income is growing at a rate equal to G. So if technical progress is 2%, output per head is also increasing at 2%. Whereas output itself is growing at G plus N. If population growth is 0, if there is no population growth, then Y will be growing at a rate equal to G that we have considered earlier. So, to introduce or to explain sustained growth of per capita income in the Solow model, we have to introduce technology. But the limitation of the Solow model is, Solow has not modeled technology. So growth, per capita income growth in the model is exogenous. And in the next class, we will give a mathematical derivation of the steady state with the technical progress. Mathematical derivation of the steady state with the technical progress.